this is written in standard form. So the 3 is in the thousand spot, right? So, wait, I didn't finish writing that. I'm going, oh, that's 3. Now, for some reason, with expanded form, now they use an x for multiplication. I don't like that, but they do. 3 times 1,000 plus, what place is that 2 in? The hundreds. So 2 times 100 plus 4 times 10 to the
40.
And then plus 6, right?
Yeah.
All right. But what they want is they want you to use exponents in it. So you're going to say 3 times 10 to the what power? Third power. There's 3 zeros. Or you could have gone immediately from here to here by going, oh, there's 3 numbers behind that. Okay? So that plus 2 times 10 to the what power? Second power. Plus 4 times 10 to the first power. Plus 6 times 10 to the 0 power. Okay? Now, like I said, now you can go, this is like a middle step, but you can go from here to here by just counting the number of places behind it. So 3 times 10 to the 1, 2, third power. 2 times 10 to the 1, 2, second power. 4 times 10 to the first power, and 6 times 10 to the 0 power, because there's no numbers behind it. Okay? Does that make sense? All right, I'm going to give you one to do real quick. You don't have to go through that middle step if you don't want to. Okay, so standard form, take that number and write it in expanded notation or expanded form. Got it?
Yeah.
One second. Okay, you should have 2 times 10 to the 4th power plus 4 times 10 to the 3rd power. Now you do not have to do the 0, but you can. You can say 0 times 10 to the 2nd power, or you can go on to the 1 and go 1 times 10 to the 1st power plus 7 times 10 to the 0 power. Did you do anything with the 0 or not? You didn't. Okay, I probably wouldn't either. Okay, so that's perfect the way it is. All right, then in this section, you had some ones that you had to plug in for the variable. Okay, and it said evaluate. So let's say you have something like this. 3 times x plus y, and you know x is equal to negative 2, y is equal to positive 1, and I do have something on this. See if you can give me an answer. Okay, when you put it in there, remember there's an understood multiplication there. So I have -2 plus 1 raised to the 4th power. Now you have to do the parentheses first before you do the exponent. So this is 3 times -1 to the 4th power. Now that 4 is only on that -1. So what is -1 to the 4th power? +1, okay? Because it's -1 times -1 times -1 times -1. So my final answer here is 3. So what you got? Good. All right, I'm going to give you one more to do like that, and then we're going to move on to the next section. Okay. X is 3, Y is -2, and Z is 4. And you're going to evaluate Z to the 2nd power minus Y to the 4th power. See what you can come up with. You get it? Okay, so Z squared, so Z is 4, so what's 4 squared? 4, well, I don't, 4 squared is 16, right? Okay, then I'm going to come over here, and then I have a -2 times -2 times -2 times -2.
For the Z squared, I accidentally wrote Z to the 4th power.
Ah, that would make a difference. Because this over right here, that's equal to 16 as well. Therefore, my final answer is 0. Does that make sense? Okay, just be careful. It's the careless mistakes that are going to get you. Okay, so that is section 4.2. Okay, moving on to section 4.3 is when we begin to talk about prime factorization and whether something was a prime number or a composite number. So if I said 23, is that a prime or a composite number? It's prime. What does it mean to be a prime number? It only has 2 factors, one in itself. Nothing else will go into 23. Okay? This is the disadvantage of you being in here by yourself because you have to answer every question. Okay? Composite numbers are numbers like 10 that has more factors besides 1 and 10. 2 and 5 can multiply together to get that. So just make sure you know the difference between prime and composite. And then we began to talk about prime factorization. What does prime factorization mean? It's the bottom row of a factor tree. The numbers, the prime numbers that you can multiply together to get something. So if I have 24, let's do a factor tree on 24. What can I multiply together to get 24? Any 2 numbers besides 1 and 24.
I can't think anymore.
How about 4 and 6? Then 4 times 6 equals 24. Are these prime numbers right here? No, so I have to keep going until all I have is prime numbers. What can I multiply together to get 4? 2 and 2. What can I multiply together to get 6? 2 and 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. Okay, remember doing that? Okay, that literally was that entire section, how to do with making the factor trees. Now I think they added, did they add? No, yeah they did. Okay, so they also put in here like 32a squared b. So they put a negative in and they put some variables in. Okay, what's going to be my first row of that factor tree? What am I going to do?
-1.
Okay, if it's got a negative, you got to bring the -1 down. Now what?
16 and 2.
Okay, because you know it's even, so you know 2 is going to go into it. So 2 and 16, what am I going to do about that a squared?
32.
Okay, a times a, and then b. Okay, now are all those numbers prime? No, so I've got to keep going until all those numbers are prime. So I have -1, 2. What can I multiply together to get 16? 2 and 8. Keep bringing everything else down. Now what?
2 and 4.
There you go. Everything else still has to come down. Still not all prime. So I got to go one more time. So all of these keep coming down. Now that's 2 times 2 is your 4. And that's your bottom row right here. So here is the prime factorization of -32a squared b. Okay? You good with that? Okay, then we turned around and we used this to find the greatest common factor or the largest number that would go into at least 2 numbers, sometimes 3 numbers. You can use a factor tree to do it, but you don't necessarily have to. Now, after we found the greatest common factor, that next week is the week that you were sick in, and so you didn't get that extra work. So this part you might not remember as completely. Okay, so if I had 12, 24, and 36, and I go, I want to know the GCF, the largest number that I can divide into 12, into 24, and into 36, and it has to be the same number. And what I'm saying is the same number has to be able to go into all 3 of those. Okay, now you can look at it and maybe figure it out, or you can do factor trees. So the prime factorization of 12 is 2 times 2 times 3. So I'm doing the factor tree for 24, so then I can do 24 is 2 times 2 times 2 times 3. 36, I have 6 times 6. So 36 is 2 times 2 times 3 times 3. Now I have to circle what all 3 of them have to have in common. Okay, and then they have that. And they also have another set of 2's.
Yeah.
So then I take a representative from each group. It's like they kick somebody out. So my greatest common factor, or the number that can divide into all 3 of them, the highest number, is going to be 2 times 2 times 3, or 12. Now, sometimes you don't need to do a factor tree. You can just look at them and figure it out. Do the same thing with the variables. Okay, so if this one had like a squared, this one had a, and this one had a cubed, then what would be added here is this would be an a times a, this would be an a, and this would be an a times a times a, and it would have one set of a's in common. So the greatest common factor would be 12a. Okay? Now, you're going to use that to factor an expression. Like if I had 12 plus 24a. Okay? What's the largest number that can go into both 12 and 24? 12. So what I'm going to do is I'm going to pull the 12 on the outside. I'm going to put a set of parentheses. And this is called factor. It is a factor. Okay? 12 times what equals 12? 1. I bring down the, whatever, if that's plus, I bring that down. If it's minus, I bring that down. 12 times what gives me 24a? 2a. I gotta have the a there because I gotta be able to do distributive property and get that. Okay? So this right here is my answer as far as factoring it goes. Okay? Does that make sense? What about, let's do another one. Say I have that, and it says factor. Okay? Now, let's say we can't, yeah, you can do a factor tree and find the greatest common factor. Or, find something that goes into both 18 and 54 for me. Mm. 9? Is that what you said? Yeah. Okay, so let's put the 9 out here. Okay? 9 times what equals 18? 2. So I have 2q, 9 times what equals 54? 6. Now, let's look. Can I divide anything into both 2 and 6? 2. Okay, so what I'm going to do is I'm going to bring this 9 over here, but then I'm going to pull a 2 out. So I have 2 times what gives me 2q. I need a q there, right? 2 times what gives me 6. So therefore, that's how I would have factored it. So really I know that the greatest common factor between those two is 18. But I didn't get there right at the beginning. Okay, and it's okay, but just keep going until you can't go anymore. Okay? Alright, so we good with that? Okay, so that brings us to 4, 5. That's the next section. 4, 5, we're using the same thing here to simplify fractions. And you did some of this on your homework, okay? So if I have 24 over 36, okay, I need to find the largest number that goes into both of those. And again, if you don't pick it the first time, that's okay, you can keep going. Okay, so let's divide them both by 6. So 24 divided by 6 is 4. 36 divided by 6 is 6. Can I divide the top and the bottom by anything else? 2. So I'm going to keep going till I can't divide the top and the bottom by the same number. It has to be the same number. 4 divided by 2 is 2. 6 divided by 2 is 3. So that is the reduced fraction. Okay, stop this and start it again.